actually recording this at the end. I actually recorded all the other examples already. Graphing 1 and 2. Talking about translation. Some application problems. So this is just an extra. If you want to watch the introduction, you can watch this video. But all the other ones are already, the other ones are actually like doing the problem. So let's talk about exponential functions and graphing exponential functions. So the definition of exponential function, we have to have the x in the exponent. So for example, if you have y equals x squared, this is not an exponential function. Okay? This is actually a quadratic function, you guys. So the condition is, it doesn't mean that it has to have an exponent. Because polynomial functions have exponents, they're not exponential functions. To be an exponential function, you must have the variable x. Okay, you have to have a variable exponent. Hey, let me highlight this. You must have variable exponent x. So x has to be in the exponent's position, okay? So let's look at a couple examples. But not only that, there's another condition. So let me I should probably just read this definition. All right. So definition of exponential function. Let b be a constant real number such that b is greater than 0. So base of an exponential function must be greater than 0, but it cannot be equal to 1. So I will highlight these two facts. These are important. Okay, I'll go ahead and write this down. Base of an exponential function base of an exponential function must be a positive number that is not 1. So no negative or no 1 or no 0. Okay, so it has to be a positive number. Has to be a positive number, but 1 is not gonna work for us because, I mean, think about it. Look at this for me. Can you have y equals 1 to the x power? What kind of function is that? If I plug in a number into x, 1 to the 7th power, isn't that just what? 1. If I do y equals 1 to the 85th power, what's that going to be? That's just going to be 1. So it's not an exponential function. If base is 1, it's actually a constant function. So we're not allowed to have 1 as the base. It only has to be a positive number. Okay, so let's take a look at some of these examples that does not meet the exponential functions condition. Okay, so look at these 3 examples for me. First one, m of x equals x squared. This is not an exponential function because, I'll add it, there is no variable exponent. X has to be in the exponent's position. So you can make one similar. You can say f of x equals 2 to the x power. This is an exponential function. This is an exponential function. But if it is x to the 2nd power, the exponent is just a number 2. So that's not an exponential function. This is actually a quadratic function. How about another one? N of x equals negative 1/3 to the x power. Well, this time it has a variable exponent, but what is wrong? Well, base is negative. Exponential function must have a positive base that is not 1. So when it has a negative base, this is not an exponential function. Okay? Last one. What about that p of x? P of x says p of x equals 1 to the x power. Oh, base cannot be 1. If base is 1, it is not an exponential function. So these red, green, and blue functions are not exponential functions. But how about the ones on the left right here? Take a look at these happy ones. The first one, f of x equals 3 raised to the x power. That is fine. 3 is a positive number. X is a variable and it's in the exponent's position. So that is a perfect exponential function. How about the next one? G of x equals 1/3 to the x power. 1/3 is a positive number, right? So this is fine. It's got a positive base. X is in the exponent's position. This is perfect. These are different. Call this an exponential growth. This is a growth function. If base is bigger than 1, it's going to be a growth function. Okay? Base is greater than 1, it's going to be a growth function. 3 is bigger than 1, so this is a growth function. Now, say that the bottom one, this one right here, this is a decay function, exponential decay, because base is okay, gotta have a condition. Because base is smaller than 1, but bigger than 0. And what kind of numbers are in between 0 and 1? Any fractions or decimals that are smaller than 1. So this is a decay function because the base is in between 0 and 1, because 1/3 is bigger than 0, but less than 1. So if that happens, we call it exponential decay function. How about the last one? The last one says square root of 2 raised to the x power. Square root of 2, if I type this into my calculator that I have on my desk right here, square root of 2 is approximately, it's not giving me a decimal. Give me a decimal. Whatever. All right, let me try another one. How about my Desmos calculator? How about I type in square root of 2? What kind of number is that? It is 1.4142. That's a positive number, right? That's a positive number. So that's fine. That's okay to be an exponential function. Let me go ahead and write this down. And this is actually a growth function, exponential growth, because square root of 2, the base, is bigger than 1. Okay? Alrighty. So I think I said enough, really. And this part right here, I think I actually come back. Oh, you know what? I did talk about this already just now. We said it's a exponential growth function if the base is bigger than 1. Oh, I just kind of talked about that above. And if the base is in between 0 and 1, like fractions like 1/3, 1/2, 4/5, decimals like 0.5, 0.7, 0.8. If you have one of those base, it's going to be called exponential decay. I do want you to watch the graphing videos because I will talk more about domain, range, and horizontal asymptote for the exponential functions. But I only have 5% left on my iPad, so I think I'm going to go ahead and cut this video short. But you will see all the other videos posted. And I will also put the PDF of this completed note on Canvas for you so that you can take a look at it, okay?